So we are finding some solutions for equations here and then doing some operations with those solutions. So first up, we want to solve x squared minus 3x minus 40 equals 0. So that's quadratic. So why don't we try to factor here on the left. So x and x need to go in the first slots. In the last slots here, factors of negative 40 that add up to negative 3. So how about positive 5 and negative 8? All right, 5 times negative 8 is negative 40. Negative 8x there, positive 5x gives negative 3x. So then product equals 0. So either the first factor is equal to 0, x plus 5 is 0, or the second factor, x minus 8 equals 0. So bring the 5 over as a negative, x is negative 5, or bring the 8 over as a positive, x equals 8. So then they have us list x1, x2, so negative 5, negative 8. The sum of the two roots here, negative 5 plus 8 is 3, and then the product of the two, negative 5 times 8, negative 40. Going to do the same thing for trinomial here now. It's 2x squared out in front. So we should still try factoring. So we've got factors of 2x squared that go out in front, so 2x and x. And then factors of 12 that go in these second slots. And we have to get outside-inside terms that add up to 5. So I'm just going to do trial and error here. So factors of 12 here, just list those factor pairs. Factors of negative 12. So we've got 1 and negative 12, negative 1, positive 12, 3, negative 4, negative 3, positive 4, and then 2, negative 6, and negative 2, positive 6. Now, outer inner terms here are going to add up to positive 5. So the 12s here are not going to work in there real well. How about we try 3 and negative 4? So this would give negative 8x, positive 3x, which would give us a negative 5x. We want a positive 5x. How about positive 4 and negative 3? So positive 8x minus 3x is 5x. So that's it. So then either 2x minus 3 equals 0, or x plus 4 is equal to 0. Bring the 3 over as a positive, 2x equals 3. Divide by 2 on both sides. X equals 3 halves. And then here, subtract 4 on both sides, so that 4 comes over as a negative. So 3 halves, or negative 4 here. Listed the smaller first. The sum of those, and just change your negative 4 to negative 8 halves. So that gives negative 5 halves. And then the product of negative 4 and 3 halves, negative 6. Try another one. 9x squared minus 16. I notice 9's a perfect square, 16's a perfect square. This looks like a difference of 2 squares. So I'm going to try and factor here. So the 9x squared, I'm going to break down as 3x, 3x. And then 16's a perfect square, so I'm going to break that down as plus 4 minus 4. And double check here. Negative 12x, positive 12x, they cancel out. That's what we wanted. So if 3x plus 4 is equal to 0, or 3x minus 4 equals 0. So here, bring the 4 over as a negative. 3x equals negative 4. And then divide both sides by 3. So x will be negative 4/3. Or here, bring the 4 over as a positive. 3x equals 4. Divide both sides by 3. X equals positive 4/3. So our x1, x2, negative 4/3, positive 4/3. The sum of the two roots is 0, and the product of the two roots, negative 16/9. And then the last one, 2x squared plus 4x plus 8 equals 0. That one doesn't factor, so we're going to use quadratic formula. Let's first divide through here by 2 all the way across. Simplify that. So we'll have x squared plus 2x plus 4 equals 0. So our a is 1, our b is 2, and our c is 4. Remember, if there's a sign out in front, you have to include that. So here's our quadratic formula. So negative b will be negative 2 plus or minus square root b squared, so 2 squared, minus 4 times a is 1 times c is 4, all over 2a, so 2 times 1. So this will be negative 2 plus or minus, let's see, this will be 4 minus 4 times 4, 16, 4 minus 16, negative 12. So square root negative 12 over 2. And then negative inside the square root is I on the outside. So this is negative 2 plus or minus I square root of 12 over 2. And then we can simplify that a little bit more. Negative 2 plus or minus I. And then 12 is 3 times 4. So we're going to break that. So let's do this here. Root 12 is root 4 times 3, which is root 4, root 3. And then square root of 4 is 2, so this is 2 root 3. So this will be I times 2 root 3. And then all over 2. And now we can factor a 2 out in the numerator. So factor a 2 out. This will be negative 1 plus or minus. Factor that 2 out. Just be I squared root of 3. And then divide by 2. And then these guys cancel. So you can write this as negative 1 plus or minus I times square root of 3. Or if you want, square root of 3 times I. Your author likes to put the I afterwards. And then let's go ahead and we first list out the x1, x2, then we add them, then we multiply them. So negative 1 minus root 3 times I, comma, negative 1 plus root 3 times I. So those are our two roots. Now we add them. Negative 1 minus root 3 times I plus negative 1 plus root 3 times I. So here we've got a negative root 3i, positive root 3i. They cancel out. Negative 1 plus negative 1, negative 2. And then multiply them. Negative 1 minus root 3i times negative 1 plus root 3i. So first terms, 1. Outer terms, minus root 3 times I. Inner terms, negative times negative, positive root 3 times I. And then the last terms, negative times positive, negative. And then it'll be root 3 times I quantity squared, because there's 2 of them. So then let's see, the negative root 3i, positive root 3i cancel out, so we're left with 1. Let's see, minus root 3 squared is 3. and then I squared is negative 1. So 1 minus 3 times negative 1, that will be 1 double negative, makes a positive. 1 plus 3, 4. And that's that question.